Here is a simple model to illustrate how screening mammography works and the concept of cancer detectability. In his seminal book entitled Breast Imaging, Dr. Daniel Copans from Mass General Hospital uses balloons as a model to describe how screening mammography detects cancer.
This slide, what it highlights is a couple issues. One, that screening mammography is imperfect and is in fact not actually designed to detect all cancers. And the second important issue is the impact of duration of screening regimen. So whether you're doing annual screening or biannual screening, what impact will that have on the type of cancers that you detect? How this model works is if you have cancers at the bottom of the screen, some are fast growing, some are medium growth, and some are slow growing. And then the dashed blue line marks the level of detectability. So once cancer gets to be past that line, then it is able to be detected by mammography. The orangish dashed line is the mark at which point the cancer is clinically problematic, meaning it's spread to the lymph nodes. It's going to have significant impact on the patient's morbidity and mortality. I have two sides here. One is if you do annual screening, one is if you do biannual screening. And if that sounds complicated, I think it'll make more sense as we progress the slide. So with the fast-growing cancer, in 1 year, fast-growing cancer will jump and get so much larger that it will already surpass the level of detectability. It will also surpass the level of being clinically problematic. This happens whether you're doing annual screening or biannual screening. That yellow shaded area between the detectable and clinically problematic lines is really the sweet spot. That's where mammography finds cancers and finds cancers before they're clinically problematic. Mammography is not designed to catch fast-growing cancers. You may occasionally get lucky, find a fast-growing cancer just based on the timing, but in general, fast-growing cancers will grow so fast and so large that they'll be clinically problematic by the time you detect them. Now, if we move to medium growth cancers, which is a huge number of cancers, in 1 year, you will see it for annual screening, it would be right in the range of where it's detectable but not yet clinically problematic. So this is where you want to find cancers with mammography. Now, if you're doing biannual screening, in 1 year you would be in this yellow range, but you're not going to detect it because you're screening every other year. In 2 years, then you're going to be up past the clinically problematic line. This point right there is why in the United States, the American College of Radiology recommends annual screening. I know in many parts of the world, in Europe, other places, they do biannual screening. You're still going to catch some cancers, but you may potentially catch some cancers, some of these medium growth cancers, a little bit later, potentially after they're clinically problematic. And then if we look at slow-growing cancers, so slow-growing cancers, in 1 year, it may still not be big enough that it can be detected by mammography. Second year, it would be in that sweet spot where it can be detected. With biannual screening, in 1 year, still not able to be detected. It wouldn't be anyway, as you wouldn't be screening that year, but by the time you're screening, you would be able to catch it. So really, you can see screening mammography is designed to catch medium and slow growing cancers. Fast growing, the only way that you could do that is by really shortening your interval to 6 months or even less. Nobody's suggesting that be implemented. So unfortunately, fast-growing cancers are really not the point of screening mammography. With annual or even biannual, you should catch the majority of medium and slow growth cancers. And these cancers are still very important as they eventually do become clinically problematic.
Thank you for watching. Please click subscribe to see more of our content or go to MAMMOGUIDE.COM to learn more about breast imaging.